Welcome, everyone. Thank you for attending this session. My name is Dennis Torres. I'm a Brazilian software developer, but living in Malta. So probably you already notice my accent. Feel free to ask any question. If you don't understand something, feel free to ask. I know my accent is not very easy. So I'm here to talk about SQL Server Big Data Clusters. Data Virtualization and Data Lake using SQL Big Data Cluster. What is this? Here, my name again, Dennis Torres. I'm a data platform MVP, trainer with some Microsoft certifications and leader of the Malta Data Platform User Group. On the right, you can see in any of my contacts, including my personal website, which already has my contacts, and both my website, the user group website, both have a lot of technical content. It was visiting them. So, what we will see today? I'll talk about what's data lake, since I'm talking about data lake. What's data lake? Merging past and future. I will link past concepts with future concepts. What's data virtualization, which is the focus of this session. What's big data cluster that we will use to implement data virtualization, and how data virtualization works inside SQL Big Data Cluster. SQL Big Data Cluster is very, very complex. It's absolutely impossible to completely understand SQL Big Data Cluster in a single session. I will focus on some features of the SQL Big Data Cluster. During this presentation, I will be available on the chat to answer any question. So if you hear any word, any technical word that you don't know yet, feel free to ask on the chat window and I'll be able to answer you. But during this event, SQL Beats, there are other 3 sessions about SQL Server Big Data Clusters. 2 of the sessions were yesterday, and 1 will be today, just after my session. So you can get more information about SQL Big Data Cluster, especially because I will not focus too much on the installation, on the architecture. I will make an overview of the architecture, but not focus too much. I'm interested on this session on specific features of the SQL Big Data Cluster. So let's go ahead. What's a data lake? First, we got big data. Internet and IoT brought to us the big data. What's big data? Basically, it's any amount of data that you are unable to process with your current resources, hardware resources, on the time you need. Basically that. You can't ingest this in a relational database. You can process this according to your time constraint. Then we're talking about big data, and we need special ways to process this. So this was mostly brought by internet, the huge number of users our application gets over the internet, and IoT. So we got big data, and big data brought what? Big data brought data lake. Why? What's the relation? It's very simple. The concept is very simple. Big data is so big that we can't keep moving it from one place to another to process it. Like, for example, using SSIS. Oh, let's import that data to here, our SQL Server, and process it. All the data here. Let's import the data for that other tool and process there. We can't. It's too much. It's too big. Then we got the concept of a data lake. Data lake, we could say that the data lake is the storage of the big data. Is the concept for the storage of the big data. And the idea is that the storage, the data in this storage will not move. You will not move this data. We'll process the data pointing to this storage. We will not make migrations to process this data in other places. You will process the data pointing to this storage. So what happens in the data lake is that you point many tools towards the data lake. So many tools will read information from the data lake to analyze the information in the data lake and generate the result we would like. Let's make a tour to the not so past. It's not that past. These concepts are very actual, but many people are forgetting them. Data warehouse. Data warehouse. It existed way before big data, way before data lake. We had a data warehouse. What is a data warehouse? It's a relational base of historical data, historical and structured data for our company. Although we don't use normal form, we use the normalized form, star models like this star model you are seeing, but it contains the history of data for the company. And it is still important nowadays. So we had the data warehouse. And then let's get back to the future, what we have today. Today we have the data warehouse and the data lake. We have the data warehouse dealing with structured data. I'm not a fan of this explanation. I'm not a fan of this explanation because if you look further, if you investigate further, you will discover that the original data warehouse definition also includes unstructured data. Yeah, it's strange. But I will not go into these details. People are getting used to identify a data warehouse as a structured amount of data. I have a blog post talking about these details about naming. It was reading. And we have the data lake. The data lake deals with unstructured data, data without a structure. For example, IIS logs, logs from web servers, and many other kinds of data which arrives from IoT and arrives in a huge volume. And we're talking about big data. Data lake is storing big data. So we have in one side the data warehouse dealing with structured data and the data lake dealing with unstructured data. What happened next? What happened next is that they got engaged and decided to marry. So they married, had a honeymoon, and the result is that we got the data lake house. The idea of the data lake house is an environment, and we may be talking about a tool supporting data lake house, where we can process structured and unstructured data together. we can process both kinds of data together. That's a data lake house. Again, I'm not a fan of this word because originally the data warehouse already included unstructured data. But take a look on the blog post that I wrote and you may understand better. Let's say your manager, the manager of your company, made a request to you. He comes to you and says, oh, we have many Twitter accounts on the Twitter. I would like to know which are the 100 people who most interact with our Twitter account. I would like to get this information. Then you start already thinking about how to get the information from Twitter. And then the manager continues. We already got this information. We have the Twitter information in HDFS storage. Okay, so you can get information from an HDFS storage. But I don't want only this. I want also that you match the information of these people with our customers' database, so we can identify how much these customers are buying, how much these customers that most interact with us on Twitter are buying from the company. Our customers' database is on SQL Server, so I would like you to integrate the information and get me a result about how the customers are interacting with our Twitter account. But remember that last month we bought another company that uses Oracle, and they also have a client database in Oracle. So I would like you to check their client database as well to ensure to check if the customers that are interacting on Twitter with us are on their client database as well. So I would like you to merge all these information, three data sources, Oracle, SQL Server, and the tweets in HDFS. At this point, you are already thinking about many possible solutions, many SSIS package to import data from one side to another side, and so on, so on, so on. But the manager continues. And I would like this for the meeting that I will have in 1 hour. You have 1 hour to make this. Then that's when you go crazy and you get a huge risk of losing your hair and become bald. That's not good. What's the secret here? The secret here is that using a data lakehouse tool, and in this case I'm already talking about big data cluster, you can make one single query, one single select, which will read from all three data sources, making joins of the data from all the three data sources in a single query. No problem with that. So, to better understand how this works, we need also to understand the concept of data virtualization. And this is very linked with the data lake. Here you are seeing a data virtualization platform. And the image is already explaining everything. The data virtualization platform is a logical data lake. What's the idea? The idea is to have a platform where you can map external data source from many places. This external data source can be on many different places, and they will be there. You will not really move them from their original place, but you map all of them to a single data virtualization platform. And this data virtualization platform becomes a logical data lake, a place where the applications will always find all the information the company has without any concerns or needing to know exactly in which format the information is, or where the information is, what the compatibility with the information. No, these applications don't need to know anything about this, because these information are mapped to the data virtualization platform and even transformed in relation of format. For example, the applications will make a simple SQL query. Just that. We're talking about SQL queries. How data virtualization works in SQL Big Data Cluster. Data virtualization tools inside the SQL Big Data Cluster. External tables. Maybe you already heard about this concept, the concept of external tables. This is linked to a feature called Polybase, which appeared in SQL Server 2016. But Polybase was very transformed from that time to nowadays. It's something totally different, something very different. And we can use external tables to link to external data sources. That was always the Polybase purpose, to link to external data sources. That's it. ADFS tiering and mount of ADFS. The technical name is ADFS tiering. What's this? SQL Server Big Data Cluster don't deal only with SQL. It deals also with unstructured data. We are talking about a data lakehouse environment. So we have an ADFS environment for our SQL Server Big Data environment. We have an ADFS environment. And the concept of tiering is that inside the ADFS environment that we have, which are, let's say, local to our SQL Server Big Data Cluster, we can mount external resources. We can point to external resources and mount these resources inside the ADFS environment, inside our SQL Server Big Data Cluster. This means that we will be able to access ADFS as if it's a local ADFS without any concern about where that data really is. We don't care. We don't need to care. We will just query the Big Data Cluster environment, the ADFS environment inside Big Data Cluster. So we already seen two tools to manage data virtualization. We can use external tables pointing to external places where we'll be able to query these places, and we can use ADFS tiering to mount unstructured data inside an ADFS structure. And the third feature is a feature called pushdown. This is a Polybase feature called pushdown. What's this? What's this? Well, mind that this is a data lake house. And considering that this is a data lake house, it's implicit that we are dealing with big data. Big data. So the idea to bring this data from another place to the place where we are is not cool. Is not good, not cool. Because we would be breaking the data lake concept if we do that. We would be breaking the concept. That's not the idea. It was not built for that. So, what's pushdown? Pushdown is when you build a query accessing many external elements. Let's say that we access an external SQL Server from another company. We access an Oracle, external Oracle, and you join everything in a single query. Pushdown is the ability that Polybase has to send parts of the predicates of the query to be processed on the remote data source. So the remote data source will not only send out the data and let us to process it. No. We will send to the remote data source parts of the predicates, joins, and everything that we can send to the remote data source to be processed outside our environment. So we are breaking the cost of the process of a query in among many data sources. So our environment, our hardware, will not process the entire query. We'll send the query to be processed on the data source and get back the results and merge according the final query. That's this example. I said we have a single query making access to Oracle, SQL Server, and ADFS. How this single query will behave? This single query will push down parts of the query to the Oracle to get the specific rows it needs, push down parts of the query to SQL Server to get the specific rows it needs, but it can't push down anything to ADFS because ADFS is a storage. It doesn't process anything. Unless we access this ADFS through a Spark pool. Yes, we could access this ADFS through a Spark pool. In this case, this single query could push down predicates of the query to Spark. If we go directly to the storage, we can't push down. So our SQL will process this part of the query. But if you go to the storage through Spark, then we can push down parts of the query to Spark jobs. So, we talked about definitions, but let's go deeper on what is Big Data Cluster. As I mentioned before, I will focus on some features. I will give an overview of the architecture, but there are other sessions in this event that go deeper on the architecture. I will focus on some features. Let's see. Big Data Cluster is a set of capabilities introduced with SQL Server 2019. Clusters. Containerized SQL Server, Spark, and Hadoop data file system with Kubernetes. We are talking about deploy SQL Server containerized in Kubernetes having many instances of SQL Server, Spark, and ADFS working in a cluster. It's a complex definition. Let's try to explain it piece by piece. First, what's a cluster? When we mention cluster on this subject, we are talking about an MPP architecture. This is a generic MPP architecture. It's not exactly big data cluster. It's a generic MPP architecture. So you can have an initial idea about how it works. The idea is that one application will send a request to a control node. The control node, what is this request? This request is a SQL query. The control node will break the request among many compute nodes. Each compute node will process part of the request, a piece of the request, retrieving part of the data. Then they return the data, and this data is merged again, and the result sent to the user. That's the idea. Why is this important? We are talking about big data. Don't mind if you are talking about data virtualization, so you push down lots of pieces of query. It doesn't mind. The amount that you reach SQL Server will still be huge. We can have huge amounts of data getting back to SQL Server. And if you stay with only one instance of SQL Server, let's say that, we will not be able to process that. So we need a cluster. We need a cluster to process the data. So now that we saw the base concept of a massive parallel processing, let's see the architecture of the SQL Server Big Data Cluster. We have a SQL Server master instance. That is it, a master instance. And many applications accessing the master instance. The master instance doesn't have the name for nothing. So it will control many other pieces. But outside this set of pieces, we have a set of control tools. Some of them may be well known by you, some may be new. We call this environment a control plane. This control plane controls and monitors the cluster itself. So, inside the cluster, we have what we call compute pools, and we can have many compute pools, different compute pools, and each compute pool can have many compute nodes. Each compute pool can have many compute nodes. So at this point you may be thinking, what are we talking about? Are these different machines? No! We are talking about Kubernetes. We are talking about pods and containers. All this is deployed in pods and containers. Doesn't mind if you will deploy this in Azure Kubernetes services, for example, or if you will have your own on-premise Kubernetes services to deploy this environment. Doesn't mind. It's the same. So this environment will be deployed inside a Kubernetes services. What this means? This means that you can easily create new compute nodes, new compute pools, and also remove compute nodes and compute pools according to your need. So, what the compute pools will do? They will access external data sources. How? We talked about external data sources as one of the ways we can make data virtualization. We create the external data sources as objects inside the database, and when we query these external data sources, the compute pool will retrieve the data for us and process our query. See, even with pushdown, the amount of data that will return may still be huge. So the compute pools will break down the processing in order to achieve the result, and then the result of each compute node will be meshed and sent back to the user. Another very interesting point in relation to the big data cluster architecture is the storage pool. We already talked about the compute pool, but we also have a storage pool. The storage pool is intended to hold HDFS files. So we have a local storage pool inside SQL Server Big Data Cluster. It's considered part of the Big Data Cluster, an HDFS pool. And inside this storage pool, we have a Spark instance capable to access this storage pool and execute jobs over this storage pool using Spark. We can use Spark in SQL now. But it's not only that. We are talking about data virtualization, and I already talked about this feature, which is HDFS tiling. What it means? Reminding, HDFS tiling, this means that I can, inside the local storage pool, I can mount one folder as a completely external place. So one specific folder inside the storage pool can be an external page in another totally different place. So again, we are getting data from different places and creating an environment which is a virtual data lake, a data virtualization platform using these features. And about the storage pool, there are two ways to query the storage pool. I mentioned that very lightly before. We can query the storage pool directly, querying through HDFS, or we can query the storage pool through Spark. We can make a Spark request, and the Spark will execute a job to read data from the storage pool. It depends what is better or not. Depends on the size of the data that you are querying and the amount of compute nodes that you have for Spark. It depends. Then, below all of these, we have storage nodes and persistent storage mapped to the Kubernetes environment, because you know that a Kubernetes environment can't store final information, because each Kubernetes container can go down and up at any time. So we have an external storage environment mapped to the containers inside the Big Data Cluster environment. Let's see a demonstration about all of this. Compute pool and HDFS tiling. I have here a virtual machine. This virtual machine is a client machine for my big data cluster. It's not a machine where the big data cluster is. It's a client machine for the big data cluster, which is installed. I decided to install because it is easy on Azure Kubernetes services. I said install is easy. Not if you don't follow the instruction. Read the manual. And what manual is that? Microsoft created an entire workshop about SQL Big Data Cluster, and this workshop explains step by step how to deploy the SQL Big Data Cluster. Your first deployment will follow these steps. Your first deployment will be a guided deployment following these steps. After that, after you get some understanding of the environment, then you'll be able to customize the deploy according to your needs. But your first deployment for sure will be a basic deploy following the workshop. You ask, where is the link of the workshop? I will show in the end. I will show the link for the workshop in the end. So let's start the demonstration. Here I'm using Azure Data Studio. As you may notice, Azure Data Studio. To deal with Big Data Cluster, Azure Data Studio is the best tool. The best. And here I can see the master node. I'm connected to the master node of the Big Data Cluster. And what's different here? What's different here is the ADFS folder. ADFS folder is completely different. Yes, we have an ADFS storage inside SQL Server. That's what we are seeing here. An ADFS storage inside SQL Server. The unmount is done, the delete of the mount is done. So now I will make a refresh, and that's it. The mounts are not there anymore. No mount there anymore. So let's start from the very beginning. It's interesting to notice the architecture that we have. First, we can go to the Azure Portal. Here in the Azure Portal, I can check the pods that we have inside the SQL Big Data Kubernetes service. SQL Big Data is the name of the Kubernetes service. And we have all these pods created inside this Kubernetes service. No, I haven't created one by one. I followed a process to deploy SQL Server Big Data Cluster, and these pods were created. Let's highlight some details here. Note that we have two pods of data, 00 and 01. This means that we have two nodes for data. The data pool that was talking about. We have two pods for storage, 00 and 01. So we have two nodes for storage. The storage pool I talked about before. But we have only a single pod for compute. Because when I built the Big Data Cluster, I asked for a single pod of compute. It's only for demonstration. Of course, it doesn't make much sense to have a single compute pod. It just doesn't make much sense. It's just for a demonstration. The other pods are control pods, pods for the master, and for the additional monitoring services, such as a problem about the certificate of an environment, and it's not important on a sample. So here I have the Grafana environment, and I can manage the environment, get pods and containers metrics, and here I can see the pods that we have, and I confirm again that we have one compute node, one compute pod, 2 data pods, and the storage pods are a bit below. I can get one data pod, for example. No, let's get the compute pod. And I can check the activity in the compute pod using Grafana. Okay, all this that I did until now is only to show to you a vision of the environment, give you a small vision of the environment. Let's start some more active demonstrations. Let me open one file, open file. I have here a quiz demonstration. I will use the sales database. First, when I'm accessing information in ADFS, unstructured information, I need to define carefully what's the format of this information. So we have a concept of an external file format. It's an object that we use to specify the format of the information. So I will create this object. Let me open sales here. Highlight that we have external resources inside the database sales, external data sources, and external file formats. And we have some external file formats already created here, because of course I forgot to delete them before, but since they are created, let's leave like that. And this is the statement to create the external file format. Next step, after creating the external file format, I can, inside the SQL database, create an external data source. An external data source in the SQL database will be pointing to an external place. So I can retrieve information from the external place. That's the idea of the data virtualization.